how you can go from sine and cosine to just tan.
So in the formula where it's like cos squared theta plus sine squared theta equals to 1, isn't there something like equals to tan or something like that as well?
So that's if it's squared. If it's not squared, it's just sine over cos equals tan.
Okay, so sine over cos. So does that mean that I need to do something like 4 sine x?
I'm just writing it
Do,
down.
yeah. Do I need to do like 4 sine x divided by 3 cos x or something?
You could just divide by cos x.
Okay.
Just keep it simple.
And that'll be, oh, that will be 4 tan x equals to 3.
Mm-hmm. And so find the value of tan x.
3/4.
Yep. Part B.
So again, would I just do cos 2x? No, divide it by cos 2x.
Yep.
And would that give me like tan? Would that give me tan x again?
Tan 2x.
Okay. So 4 tan 2x equals to 3.
Uh-huh.
And then tan 2x equals to 3/4.
Yeah, so it's one of those hence questions where you can use the previous one.
Yeah.
Okay, solve it.
So if I do the calculator, I need to then like add pi a couple of times, don't I, in the thing after?
Yes. However, make your life easy. If you have anything other than 1x, let a be equal to 2x and then do all of that stuff.
So that would just be tan or arc tan of 3/4.
Yeah.
And that will be equals to about 0.64 0.64 basically.
Say you said one decimal place, so 0.6?
Yep.
Radians. Okay.
And then do I now need to add pi to that?
Yep.
And that will give me 3.8. Oh, that's a bit too over, isn't it?
You would think so, because
2 pi, it goes up to 2 pi, doesn't it? Or
and why is that?
because there's 2x.
Yes, well done.
And so I would guess then that now I've got, do I do 0.6 minus pi?
Yep.
And that is minus 2.5. And then should I do minus pi of that?
Yep.
And that is minus 5.7.
What is next?
I need to do divide all those by 2.
Yeah.
And so that would be 0.3.
Yeah.
1.9. Minus 5/4.
1 decimal place.
Minus 1.3.
Yeah, you're right.
And minus 2.9.
1 minus 1.3 minus 2.9. And I put them smallest to biggest for whoever needs it. Minus 2.8, minus 1.2, 0.3, 1.9. So why did they round it wrong? Or did we just round it too early or something? I think they rounded it wrong. Crazy.
Yeah. Yeah.
Yeah, they totally rounded it wrong. Yeah, you would expect 2.9, 1.9. Okay, 1.3, 0.3. Any questions there?
No.
Okay. If you have a mixture of sine and cos, and you need to get tan, divide everything by cos. And then other than that, it's okay. Okay, stuff gets trickier, but it's the same idea. Follow the same steps. You'll be okay.
Okay. So I'm guessing I need to do something like let A be equals to 3 theta plus pi/4.
And that will make your life much easier.
And then do arc sine of minus 0.2.
Yep.
And that will be minus 0.2.
Makes sense. 3 sig fig.
Oh, minus 0.20.
200.
It's minus 0.201.
The first 0 has no significance.
Yeah.
So this 0 has significance. That would be the difference between, £201 and £21. But the first 0 has no significance.
Yeah. So now I need to do. Wait, does that mean that that's not an answer though? Because it's not in between 0 and 3 pi/2.
It might be. That's a good point. What is our range?
3 pi divided by 2, which is like.
No. So theta is between 0 and 3 pi/2.
Yeah.
We have 3 theta plus pi/4.
Yeah.
Do it in steps. What is 3 theta between?
0 and 9 pi/2.
And now, so theta is between that, 3 theta is between those, and now 3 theta plus pi/4.
And now is it going to be. Do I just have to. Do I need to minus pi/4 from 0?
You need to add pi/4 to everything. 3
So,
to get
yeah.
3 theta plus pi/4.
So pi/4, and then just 9 pi/2 plus pi/4.
Yeah.
And that is 19. Yeah.
Yes, so this minus answer is definitely outside of our final answer range, but let's use it to get additional answers.
So I need to add 0.201 or
You need to add what to it?
pi.
You might just have gotten lucky. Second answer for sine is it is pi minus first answer, and so minus minus becomes plus. Or
Oh,
maybe it didn't. Okay, what do you get there?
you'll get 3.34.
Oops. 3.34.
3.4.
3.34. Okay. What's next?
Do I now need to add pi?
That's only true for tan.
Oh, is it 2?
Yeah, 2 pi. Sine and cos repeat every 2 pi or 360.
So am I doing? Oh, I need to add 2 pi to both of those values, don't I?
Well done.
Okay, so for minus 0.201, that'll be um. So 6.08.
Say it again, sorry.
6.08.
Yeah.
And then the next answer will be 12.4. Oh no, sorry. I was adding on from 6.08.
Uh-huh.
Oh, I'll do the other one. So 3.34. I got for that one. I got 3.3 plus 2 point. I got 9.62.
What is 19 pi over 4 as a decimal?
14.92.
So that's 10.92. And so we can use that to see where we stop.
And then do I need to do 9.62 plus 2 pi?
Yeah, give it a go.
Oh, that'll be too far, won't it?
Yeah, it'll be too big.
So these are my values. Then I just need to now make them equals to theta.
They are all equal to a.
Yeah.
What is a equal to?
Arc sine minus 0.2.
What else is a equal to? What did we let a be equal to?
3 theta plus pi over 4.
Plus pi over 4 is equal to all of those. How do we get what theta is?
I just need to solve for theta.
Yeah, how would you do that?
So for the first one, I'd do 3 theta plus pi over 4 equals to 3.34, or even 4.201. So see if that works. So
minus 0.201 won't be, because we got it in terms of 3 theta plus pi over 4. And so we know it won't. Make your life easy. If they were all equal to 3 theta, you would just divide them all by 3. You could individually solve each of them, or you could just subtract pi over 4 from each and then divide each by 3.
Yeah.
It's same thing. Okay, go for it.
So for 3.34, do I minus pi over 4 then?
Yep.
And so I get 2.55.
Yep.
And then for the next one, for 6.08, I get 5.29. And then for 12.4, I get 11.6. Oh, sorry, I missed out 9.62. But yeah, that was 11.6. Yeah, and then for 9.62, I get 8.83. And then I need to now divide all those values by 3.
Mm-hmm.
And so for the first one, it'll be 0.85. Next one will be 1.76. And the next one will be 2.94. And the next one will be 3.8. Oh no, 3.87.
Okay, so these might all be slightly off or some slightly off because, yeah, we definitely, with this level of stuff, like first subtracting pi over 4 and then dividing by 3, we definitely should keep our working out to 5 sig fig and then just round to 3 sig fig at the end. Let's see how we did. So 0.853, so we lost a little bit of accuracy there. We said 0.85. 1.76, so they're saying it's 1.77. I'll trust them. 2.94, so they're saying 2.95. And then 3.86, we said 3.87. Yeah. So questions like this, we definitely need to keep the 5 sig fig. I didn't think of it until the very end. Okay, that's 4 marks. Whoopee. For question A, how about question B?
So that's a bit strange.
A mixture of cos and tan. I think you could turn tan into sine over cos.
Oh yeah.
So what would that be?
Would I have to do 4 cos x equals to 6 sine x over 6 cos x?
Just 1 cos x.
All right. Yeah.
6 over 6 would make 1.
And do I now need to do 4 cos x times cos x?
Yeah.
And that will be 4 cos x squared equals to 6 sine x.
Mm-hmm.
Then would I minus 6 sine x to get 0?
Yep.
Or even would I have to change like sine to be 1 minus cos x? Or even the other way around actually, where I make cos squared x equals to the same as 1 minus sine squared x.
Yep.
And expand the brackets, and then I need to do something like sine x. Oh no, let a equals to sine x.
Yep. I think you'd be fine
After
for
I've
this.
yeah.
Yeah. So that one's like one what we did last week. Yeah, it's just quadratic. And then you get these answers. Okay, good. Let's see. Yep, we didn't do part A last week. Okay, any idea how you do part A?
I'm gonna guess I need to change tan into cos and sine.
You could. GCSE 1 plus x 5x minus 2 equals 0. Solve it.
X equals to -1 and x equals to 2/5.
And so here's that idea for the one above.
So simply just doing tan. Oh right. So just tan arc tan of -1, which will minus 1/4 pi. Also, then just doing arc sine of 2/5. And that'll give me 0.412.
Let's say 5 sig fig.
0.41152. And then do I now need to do the adding of pi and so for tan I need to add pi, and then for sine do I need to add 2 pi?
For tan you add pi, yeah, you get 3/4 pi. For sine, your third answer would be that plus 2 pi. What would be your second answer?
Just my second answer would that just be 3.55?
Where did I see it?
Second answer will be pi minus first answer.
Yeah.
And so that will be I got 2.73.
I think those are our answers. Between minus pi and pi. 0.412, 2.73. Yep. And then the other two were minus pi over 4 and 3 pi over 4. Great. And then part B is similar to the one we did last week, which is sine over cos, and then it'll be a quadratic. Any questions about that?
No.
Two brackets being multiplied by each other. Either the first one's equal to 0 or the second one's equal to 0, and then just solve as normal. Yep. This malarkey.
So yeah, so draw a triangle needs to be drawn.
Oops. Yeah, it's not the easiest. A to B is 5. A to C is 4. A, B, C is 0.5 radians.
A, C, B is X. So they want me to use the sine rule. So do I need to do sine X over 5 equals to sine 0.5/4.
Mm-hmm.
And to get sine x, I just need to do 5 sine 0.5/4.
Yeah.
And that is 0.599.
Okay, B.
So I now need to do arc sine of minus answer,
Mm-hmm.
and that will be 0.642.
Oops.
And I need to just do pi minus that answer,
Mm-hmm.
and that will be 2.4. Oh no, 2.50. Sorry.
2.50. And so they said two answers to two decimal places, 2.50 and 0.64.
Yeah.
0.64 and 2.50. Great. Any questions there?
No.
And you can see here why it's the pi minus 180 minus.
Yeah.
The first one was this, and then 180 minus gets you the other one. And so those trig equations, x1/2 ortic.
I think I'd give it a 2.
Okay. And we could do wacky calculator stuff. We didn't need to. Small angle approximations, the last thing for this chapter. Kind of, it'll be like easy compared to this previous stuff. He says, when theta is small and measured in radians, shift, setup, angle unit radian. Let's say sine 0.1. What will my answer be approximately? Sine theta is roughly theta when theta is small and measured in radians.
So it'll probably be 0.1 or similar to 0.1.
And it is 0.0998, which is very close to 0.1. So it's just a kind of rough approximation. Tan theta is roughly equal to theta, and cos theta is roughly equal to 1 minus theta squared over 2 under similar circumstances when theta is small and measured in radians. You can see why this is by looking at the graphs. I'm sure you can. Okay, let's do these.
So okay, so would it be theta plus theta over 2 theta? So would it just be equals to 1?
Sine 2 theta won't be roughly equal to theta.
Will that just be 2 theta?
Yeah.
So 3 theta over 2 theta, and that'll be equals to 3 over 2.
Yeah. And B.
So would that be 1 minus 4 theta squared
Mm-hmm.
over 2 minus 1 over over theta. Oh no, over 2 theta squared. And so I think that would come down to something like minus 4 theta squared over 2 divided by 2 theta squared.
It's in a bracket, so they're both squared, the 4 and the theta.
So should I just do something like minus 16 theta squared over 2 divided by 2 theta squared?
Yeah.
And would that just come down to 4 theta squared? Or even 4, sorry.
Yeah, and so final answer?
Minus 4.
Minus 4. Hope so. 4. Yeah, I thought it would be 4 because it's an angle. Let's see. Minus 16 theta squared over 2. They just lost the minus.
Yeah.
Yeah, no explanation, just lost it. Okay. Any questions about those?
No.
It's just substitution, really. Okay, how about this? So will that just be 5 theta plus 2 theta minus 1 minus 2 theta squared over 2. And now I need to do 7 theta minus 1 minus Minus times minus?
plus plus 2 theta squared.
Yeah, 4 over 2 is 2. Make it look like their one.
2 theta squared plus 7 theta minus 1.
Minus 1. That's it. B.
Hence, do I need to now do? Oh, I'm guessing I need to find the value of theta if it was equals to 0.
Okay, what would you get?
Minus 7 plus root 57 over 4.
How'd you get that?
I just put into the polynomial calculator.
Oh, this whole thing is equal to 0, is it?
Yeah.
I don't know. My guess was theta is approximately equal to 0. That you sub 0 for theta because theta is small.
Oh, yeah.
So what would you get there?
Minus 1.
So It'll be -1 degree radian, my guess. It's approximately -1. So for small values, it's approximately -1. Theta squared and theta will also be small, so you can disregard the terms. Yeah, so theta is small, so you just replace it with a 0. Okay. I think the big one there is to put this in a bracket.
Yeah.
Minus cos 2 theta, so that cos 2 theta is in a bracket, minus on the outside. If you're subtracting that, that's the same as expanding it by -1. That might help. Any questions about that?
No.
These are all right.
Yeah.
Okay. Exam question.
So I just need to sub in 0 for theta, or
Not yet. You would sub in using our values here. I don't know if these are given to you. Surprisingly, I think they might be, but
yeah. So do I need to do something like 1 minus 1 minus 4 theta squared over 2 divided by 3 theta times 2, or even, shall I just go straight to 6 theta squared?
yeah, okay.
And so that will then become, so 1 minus 1 plus 2 theta squared over 60, and then it'll come down to a third, I think.
Yeah. And I don't know if I would have seen a third if we just sub straight in there. 1/3. It's a bit more complicated, but it looks like it's the same idea. No, actually, we better do part A.
So that'll be 4 times 1 minus 9 theta squared over 2 minus 2 plus 5 theta, all divided by 1 minus 2 theta. Well, and so I now need to expand the brackets and get 4 minus 36 theta squared over 2, or even minus 18 theta squared. Minus 2 plus 5 theta over 1 minus 2 theta. And then I think that will come down to 4, or even, sorry, so if I simplified the numerator to just be 2 minus 18 theta squared.
Yeah, don't forget the 5 theta.
Yeah.
So I'll put the squared first. Okay.
And then
Factorize the top.
and so that will come down to be 2 theta minus 1. Or even it might be the other way around. It might be 1 minus 2 theta. There's a minus at the front.
Okay.
And would it be 9 theta plus 2?
9 theta plus 2. And yep, so then that would cancel. And you're left with just what they wanted. 9 theta plus 2. Part B.
So I'm guessing this is why I just need to like. So would it be 2?
Yeah, so this one turns out it was a quadratic and you had to factorize it. And my guess was the top bracket would be 1 minus 2 theta for one of them so that it will cancel down and not be a fraction. Any questions there?
No.
That's all right. Let's see. Given that theta is small, use this small thing for this one. Oh, it's very similar, but we better. Okay, how about this?
So will that just be 3 theta minus 4 times 1 minus theta squared over 2 plus 5 over theta plus 1. And then do 3 theta minus 4 plus 2 theta squared plus 5 over theta plus 1. And then if I simplify the numerator and I get 2 theta squared plus 3 theta plus 1 over theta plus 1. And then I just need to factorize the numerator. And that would be 2 theta plus 1 and theta plus 1. Cancel out both. And then you're left with 2 theta plus 1.
Any questions about that?
No.
Nailed it. Okay. Why? Okay. How about this one?
So I need to do 5 times 1 minus theta squared over 2.
Yeah, I think we're gonna be okay for A. Is it worth doing, or?
I don't think so.
I think we're okay. I didn't realize there was a part A. Okay, so how about part B?
Or actually, sorry, when it says cos squared theta, would that just mean we have to do it twice?
Oh yeah, that's just that bracket squared. So 1 minus theta squared over 2 times 1 minus theta squared over 2.
Alright.
And then times 5.
Okay, so I'm not sure what's happened.
Do
Yeah.
you remember at the start? Oh, wrong calculator. I said sine 0.1 and it was very close to 0.1.
Yep.
So he did that same thing, except with 10. And when he did it so if I did sine 10, what answer should I get?
Something very similar to 10.
Okay, and it's nothing similar to 10, and that's because 10 isn't small. It's not a small angle. This is only true for small angles like 0.1. So he did it for 10. He got 2 very different answers, and he said, therefore, this approximation is not true for theta is equal to 10. Is he correct?
He is correct.
Give full reasons for your answer.
He's correct because 10 isn't considered a small enough number to sub in.
I'd say he's correct. 11.67 is not approximately equal to minus 788.
Yeah.
Yeah, but yeah, it might be true for like 0.1 or something. Josh is incorrect as he used degrees. Josh, what are you using degrees for? I didn't even notice that. Okay, Josh used degrees like a fool. And that radians, he should substitute 10 pi. Oh wow, so 10 degrees is a decent approximation. And actually I'm in radians. And so I'm using I was using 10 radians, which is like more than like about 3 pi or something.
Yeah.
So that's pretty big. It's like more than 360 degrees. So definitely big. Okay, so he used degrees and not radians. That's one to watch for. All right, let's just watch out for that one. Small angle approximations.
I'd give it a tick.
Easy peasy. And then that's that chapter done. Let's see. 2 pi radians is 360 degrees. Yep. You need to learn exact values. Fair enough. No, you don't. Just use calculator. Solving them. Yes. Arc sine, arc cos, arc tan. Second answer for sine. So I've never used this way of writing it. Second answer for sine is pi minus first answer. For cosine, it's 2 pi minus first answer. Tan, it's pi plus first answer. And then all of them, you just do plus or minus 2 pi, which is like 360. Arc length is r theta in radians. Sector area, a half r squared theta. And then area of a segment, a half r squared theta, theta minus sine theta, fair enough. And then we had those small angle approximations. We can start chapter 6.
Yep.
It's also trig.
Oh, no.
And arguably the hardest in all available, I find. Okay, reciprocal trig. Have you seen this before? Secant, cosecant, cotan?
No.
It just means 1 over. So tan is sine over cos, and so cotan is cos over sine. So you're just flipping it.
Okay.
See. And the way you do these as well, the third letter matches up. So the third letter in secant is C, and so that's cos, 1 over cos. Third letter in cosecant is S, so that matches up with 1 over sine. And the third letter in cotan is T, that matches up with 1 over tan.
Okay.
Okay, we're back in degrees.
So do I need to now change my calculator to degrees?
Mm-hmm.
How do I do that, sorry?
Graphical, is it?
Either, yeah.
Shift menu for setup.
Um,
And you have to, so shift menu, and you have to be in a menu to begin with, like in row matrix. So. Then you go down to angle.
sorry. Did you start off at menu?
You have to start off. So press like F1 to be in run matrix or in one of those things.
Yeah.
And then you can do shift menu for setup.
Yeah.
Go down to angle. F1 for degrees, I believe.
Yeah.
And yeah. Okay, secant 280.
So do I just need to do 1 over 280 or 1 over sine 280?
What is the third letter in sec?
Cos.
Yeah, it's C. So 1 over cos.
Okay. Yeah, I got 5.76.
5.76 degrees.
Yeah.
Okay. B.
So that would be minus 0.47, or even minus 0.4676, and then yeah. Oh no, 6, sorry.
6, yeah, 5.76 and minus. Okay. Any questions there?
No.
Okay, let's try these. Should be similar.
So the first one is minus 2 root 3 over 3.
Next one.
So is this 1 over what sec would be?
Third letter is
So is it 1 over sine 3 pi over 4?
Yeah.
So there's cosec, sec, and
cotan, which was this previous one.
yeah. So I got 24.3.
We want exact values. Put in sine 3 pi over 4. Oh, that's in radians. That's why. Change the calculator to radians because it says pi.
Right.
That's sneaky.
So anytime it says pi, you know it's radians, not degrees.
Yeah, for angles.
I got root 2.
Root 2, and I did sine, and so the reciprocal, and then the calculator automatically rationalizes the denominator. So that's root 2. Minus 2, they had minus 2 over root 3. Our one is the same thing, it's just rationalized. Minus 2 root 3 over 3.
Yeah.
part B is root 2. Great. Any questions?
No.
Part A is correct. It's just ours is rationalized. Ours is a bit better, I'd say. All right. What's this? Exam question.
So this will be root 3 over 3. And then root 3 over 3 minus root 2.
Mm-hmm.
And so that will be like root 3 over 3 minus root 2 over root 2.
Calculator.
Oh, yeah, okay. Yeah, it gave me all the answers.
What?
Root 3 minus 3 root 2 over 3.
Root 3 minus 3 root 2 over 3.
Yep.
And I'm just going to put the whole thing in one go. And I get the same thing. Root 3 minus 3 root 2 over 3. Root 3 minus 3 root 2 over 3. Great. It's that stuff. Secant, so cosecant, cotangent.
I'll give it 6.
And so what you're about to embark on is the hardest chapter in all of A-level, I believe, to the point where I'll skip most of section 2, which is just graphical. Not the best teaching, but is necessary for the next stuff. Yes. How was that for you, Andrey?
That's good, thank you.
So our next lesson is on Tuesday, I believe, is it?
Oh, yeah. Would you